Hi everyone, so in today's video we're going to be talking about the wiring loom. We're also going to do a little bit of work on the side pods. I'd like to say that this is going to be a relatively short video and that it's going to be super fun. Wiring is not fun and it's pretty difficult to explain in isolation. So look, I'm going to do my best and I am shooting off the cuff there, so it's not like it's going to be some predetermined or amazing educational program. But look, I hope it has some good information. I will be putting up sort of some written notes so that if people are interested in their building their own car, it might be a little bit more useful to them. And I'll also give some information on my particular loom. You're able to get a copy of the wiring diagrams and sort of modify themselves. If anyone does have CAD and wants those in AutoCAD, I'm happy to provide them as well. You know, at the end of the day, it takes me a little bit of time. It's taken me a bit of time to put together the sensors and all of the connection pins, and my wiring harness and layout is going to have all the connectors and all the part numbers, which realistically you could adapt to certainly any LS motor, but almost any motor in general. Anyway, look, as always, if you have any questions or comments, leave them down below. You can follow along on Instagram. We are starting to get to the pointy end here, so I have actually purchased another vehicle to go on with this. Obviously, it's great to have the Ultima for the weekends, but I do need to have another car, and it's going to be a great project car that we're going to follow on with. You know, things that maybe a little bit more practical, like you know, we need to think about cost, fuel economy, tyres, all of these sorts of things are pretty important if you're talking about something that's maybe a little bit more mainstream than the Ultima. So look, I guess if you have any guesses about that sort of thing and what I should buy, then by all means drop a comment down below and we'll see whether anyone gets close to what I'm going to build. But look, I think that'll be a pretty fun project once we get into the pointy end of the Ultima here, and certainly it should keep things going into the future, and maybe give something that's, you know, slightly different and a bit of fun as well. Thanks very much. We've finally got a fine enough day to do some spray painting, so I've just been sanding the side pods. The reason I'm starting with these is because pretty much everything on the side pods is going to be concealed, but part of this process is we paint all of the I guess underside surfaces black, so that, for example, when you're looking through the carbon side pod there, you don't see this random white unfinished sort of fiberglass section. What I'm using for it is not what the factory recommends. What they recommend, I think, is a polyurethane paint. Fundamentally, you can't get that stuff in Australia, or you are needing a professional spray booth. Part of the reason being is that it's absolutely horrible for your health. So what I got was this VHT self-etch primer. This was sort of the thing that I'd researched and found to be the best or recommended for fiberglass, because it specifically mentions that it's good for fiberglass priming. So it just says basically, you know, sand this back with 240 or 320 grit sandpaper, use some wax and grease remover to wipe it all down and remove all the crap, and then you'll have a keyed surface that is clean enough for it to bond to, a couple of coats. And the reason I haven't been able to paint this is because it says do it between 16 and, I don't know, 25 degrees or something like that, but being winter here where I am in Australia, we haven't been able to deal with that. I was thinking about using the Raptor liner underneath this sort of stuff, but I'm going to use this stuff here, which is KBS Blacktop Chassis Top Coat, and it says it's a flexible liner that pretty much you can use on anything apart from exhaust systems, and it is tolerant of much higher temperatures than what I found the Raptor liner to be, or whatever it is, Raptor liner or Bully liner or whatever the hell I've got. Obviously, the big thing for that is I'm sort of using this as a test piece for doing the under the clam section, under the front section where the radiator is, because that's obviously going to get exposed to some reasonably high temperatures. It seems like a good place to use it. This stuff is self-leveling, so you do need sort of protective equipment like an actual respirator and stuff like that if you're going to spray this stuff, but you can just use a paintbrush and you should get a reasonably nice finish. Again, I usually prefer to spray stuff because you end up with a more uniform sort of section there, but from my point of view, if I can use this stuff and it comes up with a nice finish and sort of self-levels and doesn't look too rubbish, then I'll go with that. I mean, being realistic here, this is fiberglass, right? So it's not gonna, unless you wanted to use like a ridiculous amount of high build primer and sanding and all this surface prep to try and get that all smooth, you're never gonna have sort of a shiny type of under you know, fully painted 2-pack type finish that you get in any other sort of OEM bonnet application, or even the finish on, say, carbon parts or plastic parts. So it's one of the downsides of fiberglass. No one's going to see it, but we want to make it look as good as we possibly can. So I guess we'll get to wiping this down. I've already spent hours sanding this. Light sand is a bit of an ambiguous thing, but I just, you know, I ran the 240 grit over it a few times, make sure I got all the spots. We're also going to have to measure up the side. There's sort of like a vent that runs through the side section there to ventilate the front right and front left wheel well. Of course, I've taped over this one. Anyway, it goes in there. I'm going to measure that up and then hopefully print a bit of a template that I can use for building a carbon fibre version of it. The factory does sell them, but they're reasonably expensive and apparently a bit of a pain to fit. So I thought I'd give that a go myself and maybe have a template for the future if I build another one of these or someone else needs a part. We can see here the black paint has dried and it seems to have done its job really. I'm not sure how you can tell whether the adhesion's good, but it certainly won't scratch off and it seems to have formed a pretty tough and sort of consistent coating. It was just hand painted, but you can see that you know, it has leveled out as good as you would expect, given the fact that it's obviously just rough fiberglass underneath there. We also fitted the sort of, side seals here, the carbon side seals in these panels here. These are just riv nutted into the bottom section of the side pods, and if this will straighten up, these side scoops here, you can see there's a retaining plate up here and just a section there that clips in at the front. What I'm not particularly happy with is just this bottom lower section there. You can see that it's sitting out a bit. I don't know if you can see here. There is a bit of a gap here, just so the finish isn't completely neat. So we're going to have to look at doing something there to pull that back in. I'd say that probably what I'll need to do is virtually replicate that plate that's in the top corner up here and try and sort of bond something in there to pull it back in. I don't see any other sort of solution being all that great, especially if you want to keep it removable in the future. It's consistent on both sides, so it's obviously just the way that the mold for the carbon fibre comes out. So that's sort of not ideal, but I'll need to come up with something there. I don't really like riv nutting into the fiberglass in particular too much. So what I'm going to do on the other side is I'll probably run some of that double-sided tape that you see pretty much used widely for you know, like those windshields that go on the side of your drivers and passenger door on cars and that sort of stuff. That seems to bond unusually well. Just that 3M double-sided tape would be a good recommendation there. Obviously you could use the black sort of sticker flex type stuff or contact bond that you get, but I'm not all that jazzed with that because I want to make them, I guess, still removable so that I can clean down that side, which will get I assume dirty from time to time. You can see that there's obviously crap's just going to collect in there. And we're going to need to use some paint protection film on the underside of that to protect that in the future. We can see here now the cutout that I'm going to need to work out here so that I can do those, well, I'd say they're more wheel well vents as distinct from providing anything in regard to brake cooling. You can see it's quite a complex shape, so what I did is I got some thermoset plastic and sort of used that to get the angle between the two faces there, which will give me an approximation. And then I'll sort of just map this out with some cardboard, transfer that onto some paper into CAD, and then use that as a basis for my 3D print. And then I should be able to have just a fairly neat cutout there with a little lip on it that matches fairly well. And then I'll need to just, I guess, progressively, cut that down so that it matches the face on the other side there, and then use that to cut back through the other side. Anyway, I'll show that process, but that's what we'll be working with. Alright, so I'm going to try and give a bit of an overview about how I built my wiring harness for my car. To give some perspective as to why I sort of went into this and didn't just pay someone else to do it. I don't particularly love wiring, but I do think that doing this as a process does teach you a lot about your car, how all the sensors work, what they're for, and give you, I guess, some sort of understanding and an appreciation for why you might need those sensors, which then flows on to if you're tuning your car or you're diagnosing any faults about how you might fix those. So in that regard, it will teach you a lot about your car. It isn't exactly a glamorous thing to do, but I can highly recommend it, and to some extent it's really good having been through the process on the Ultima to sort of look back at it and get that stuff right. So if I do have any issues in the future, or if I want to make amendments, say I want to go and install a traction control system or something like that, I can pretty readily wire that in. The quote I had for building the wiring harness in the Ultima was actually $7,000 Australian. Now that is obviously an extraordinary amount of money, which is why I upskilled and did some work myself to sort of get my head around exactly what was required, and like having done that, I'm pretty happy with the fact that I spent probably in total let's say $2,000 in tools, materials, wiring harness components, sensors and that sort of stuff to build it myself. So I'm sort of $5,000 better off, and I learn a lot in the process. Now I'm not an auto elec. This is the way that I've gone about doing it, and I'm sure there'll be guys that have their own perfected method. But there are some general rules I'm going to try and run over, and hopefully that'll help anyone else who's who's having a crack at building their own harness themselves. In terms of tools to do this sort of stuff, pretty much you're going to need a decent set of wire strippers. Simply trying to strip them by hand isn't sort of the best way to do it, because you're going to want a consistent strip that doesn't harm the copper under any circumstance. You're going to want a decent set of ratcheting crimpers. These ones here were about 70 bucks, and then another 25 bucks for the jaws. These are interchangeable, so you can get them to do open and closed barrel crimps. Generally for these types of connectors, they're not Deutsch type connectors, so you'll be using an open barrel crimp, and it's a matter of running test connections and test crimps to actually determine that you're getting a good crimp on the terminal, and that it's actually going to do what it needs to do. There's no sort of fancy way of working that out. Even the best auto elects, they do test crimps, and that's how they work out that they're not going to pull out. They make a good connection, and that's how that's all going to work. Obviously a multimeter, not for anything too technical, but you do need to bell out your connections once you've done your ECU and run all your wiring and that sort of stuff, so that you can actually make sure that all those connections are true and working properly. It's much better to do this at the start than it is to try and run into a fault and have to diagnose it. I do recommend a heat gun. This is about 150 bucks. It's a DeWalt one. The reason that I bought a new one of these, I've already got a heat gun. It came with a nozzle that obviously gives you a very accurate way of running it along your heat shrink, which is quite useful. It also has some adjustability in terms of temperature, which is good if you're trying to use your heat shrink and get it to move into position without melting the shit out of everything else around it, whereas my other gun is just an open-faced standard dog. This one also sits on the bench quite neatly, which has been quite useful. Other than that, I did get a fancy Dymo label printer, which enables me to print on heat shrink. That's really useful for being able to label your harness. I like to over label everything, label things on both ends. Obviously at the engine end, I like to put the connector that is relative to it at the ECU. At the ECU, I like to put the sensor as a label, so you know what it's connecting to at the other end. I just find that useful. If you ever need to bell anything out or there's an issue, you can see immediately what's happening. That's the Dymo label printer that I got. This is pretty much the minimum spec that you need to be able to print on that heat shrink. The heat shrink is expensive. I was using it pretty much with no care whatsoever the other day because I forgot that it was about 50 bucks a roll, and it's only 1.5 meters. Now I've run out, which is pissing me off because I'm partway through my harness and I need to finish it off. But look, they're the main things that we're doing. Obviously, get a decent set of side cutters. These little ones here that have a great degree of accuracy and a super sharp are really useful. Other than that, I suppose in terms of wiring tips, I think the first step is to list out all of the components you need to run your engine and really have a good think about that. If you aren't tuning the car yourself, definitely have a chat to your tuner and make sure that you've got all of the things that you need. There's no point, finding out later that you've only got, say with the V8, you've got one O2 sensor allowed for, and you really should have two to make sure that you balance between the banks. In older engines certainly, or if you're using something like a Holley Sniper EFI system, they run 102 sensor, and they pretty much assume that both banks are going to be relatively balanced. When you're starting to get to higher end stuff, you want sort of, I guess, a greater degree of resolution on that sort of stuff to make sure that you're balanced between the banks. And in the best case, you'll actually see guys run O2 or exhaust temperature sensors on each of the exhaust runners to make sure that you balance cylinder to cylinder. But that's not something I need to do. I'm not quite at that level. Potentially on a dyno would be quite good to use. Then you want to determine what each of the components that you're running in your engine require to operate. Do you need a 12 volt signal? Do you need a 12 volt power source? Do you need a 5 volt power source like most of the sensors will run? In the case of the Emtron ECU that I'm using, if you want to know why I chose that, look back in one of the past videos. It runs an 8 volt sensor to the crank angle and cam angle sensor, and then it runs 5 volts to all of its other sensors, and you can power your O2 heater directly off the ECU, so you don't have to have any external controllers or any external relay, which is quite good. It ties up all your harness, and it also enables you to power quite a few things, like even the drive-by-wire motor you can run directly off the ECU. Okay, so the first step in all of this is to list out all of the components and check that you've got sufficient, I guess, readings and inputs to your ECU so that you can run the engine and do what you want to do. Implicit in that will be obviously some communication with the tuner for your vehicle, or if you're going to tune it yourself, you need to get your head around what would be required to control your engine and say potentially your traction control or whatever like that as things become a bit more complex. Personally, what I like to do is I like to get each of these components and list out exactly what they require to operate, whether that's actuators, sensors, motors, whatever. I like to get the pinout information, the voltage and current requirements of each of the devices, and I typically do a snip or take a graphic of this information and add it to the wiring loom dock later. That is a bit of a time consuming thing because lots of these things you're going to find is a bit painful to get information on. The reason I like the Bosch Motorsport stuff is typically you can look up, for example, here is my fuel pressure and temperature sensor, and it will give you a corresponding electrical connector that goes into the back of that, and also it will tell you exactly what the pinout information is on this connector. That's really useful when you start to put this stuff together and start to wire it in. There's not really a database for that sort of stuff. A lot of the time it's really painful to try and get that information together, but it's just another reason why, you know, going to a quality sensor with quality technical information is really important. You know, as I think a lot of people have said to me before, if you put shit in, you get shit out, and it's important that your ECU has the best information that you can get to make the best decisions in terms of running your vehicle. Anyhow, that's pretty much what's required for that. Then once you've got all your sensors together, I'm going to stick this up here and try not to tip it everywhere. You're going to need to look at a power diagram. I typically like to split things into looking at the power side and then looking at the sensor side. This is an old printout, so I'll put the actual final detail up on the screen. And I'm happy to send this to anyone in terms of, if they have an LS type motor or even anything else they wanted to base it on. I'm happy to send this stuff out to them. So you're going to need to classify each of these components into sort of three main groups. The first one is going to be powered off the main relay. These are usually the master type items like your ECU. And then you're going to have controlled or enabled power, which is powered off the relays or switched by the ECU or ignition. For example, drive-by-wire type thing. I know that this ECU and lots of ECUs will have their own requirements in terms of power. This one in particular switches the main EFI relay itself so that it gives itself the opportunity to shut itself down and go through a logging, storing and calibration setup before it turns itself off. So look, that's just something that's probably going to be specific to ECUs. As to why I'm using an Emtron KV8, you can go back and look at one of my early videos and I'll give you the rundown on that. And then finally, then you're going to have dedicated power, which is usually devices that require higher current, like, fuel pumps, or if there's anything that's, potentially temperamental or a high risk item that might be best on dedicated power, that's where you look at that one. Then you need to just go and group those in terms of how you would want to provide power to those items. For example, here we've got the main EFI relay that's going to provide power to the injectors and power to the coils. And you can group them together. You do need to also look at the current draw on each of these devices and your cable sizing to make sure that you're going to be able to make all of that work and that you can have appropriate overcurrent protection and relay sizing to suit that. Now, I guess the next step after that is to look at considering your grounding. This is the biggest cause of drama. The amount of shit fights that people have with poor sensor readings and all that sort of stuff, a lot of that is really just caused by really poor grounding. Avoid electrical interference or noise by earthing all of your power devices at the engine block. So that's stuff like your coils, whatever. And then you want to earth all of your sensors at the ECU ground pin. Now, depending on your ECU, this one has multiple connectors. You generally want to try and earth all of your connectors that are connected to that particular connector at the ground pin on that connector. There are some ECUs that enable you to, ground a lot of different things on different connectors and that sort of stuff. But as a general rule, just follow that as practice and you won't run into any dramas. And so that's sort of my recommendation for that. Obviously, for practical reasons like a fuel pump, it's going to be a bit of an anomaly to this situation. And you need to just make sure that, because you're going to ground it at the opposite end of the car, you're not going to run a ground all the way to the front in a front engine car, for example, if you've got the battery in the front. you're going to need to just make sure that you get a really good earth strap between the chassis and the engine block. Base all of your ground wire sizing in conjunction with its supply counterpart, and run all of your power grounds back individually, and only combine the termination at the engine block. So you need to not just, connect all your grounds together and run a small gauge wire back to your engine block. Try and get them all back to the engine block and then consolidate them there. That can create a bit of an issue down the track. Apart from that, we then need to just go and determine the layout of your harness and branch points. In this case, you've got actually 4 of these. I think these are called Super Seal 1.0 connectors, which is probably just named that way because nerds wanted to sound cool. You actually just push that little white detent there, and it will poke out the other side, and then you can yank the wires out to depin these, or in fact pin them in the opposite direction. But you're going to need to look at the layout of your harness. Now, what you would do in most cases with this sort of thing is you would have either one big connector or a whole bunch, in this case, of smaller Super Seal connectors. You then need to work out all of your wire gauge sizes to all of your sensors and that sort of thing. Crimp them all, plug them into the back of those connectors to go into your ECU. And then what a lot of the time people do is they'll run usually some heavier gauge rope. So for me, here's my ECU sitting in the front of the bin here. It would run up and through here, and I'd run it back out to the engine. When I was doing that, what you can do is you can replicate that path with rope, and then just sort of zip tie off all your branch points here as it goes into the engine and goes to each of your sensors, whether it's a knock sensor down there, or whether it's the idle air control valve up the back there, or some of the map sensors up the back here, or whatever. And you would just sort of branch off and make sort of a bit of a, like a dodgy wiring loom out of rope to make all of that work. And then you would come back here to your bench and fit it off. Now, in this case, what I did is I bought a pre-wired loom from Emtron. It actually works out cheaper for me to do it this way and saves me running a shed load of cable into each of these connectors. I just pull out all the redundant ones, and I potentially have to splice in a few extra, power or grounds or whatever like that to suit my particular application. But it's infinitely faster and easier to do it this way. I think this might have been, this is TXL, it's not TFCL wire, which is slightly fancier, but this is more than adequate for my application. This might have been sort of $750 for this whole thing for all 4 connectors, and they separate that out quite well. There's sort of one here I'll use as an example that does just your O2 sensors. This is connector A, and it gives you all the pin out, and I've sort of put this together. But on other ECUs, you might just have one big old connector that'll run it. So look, that's the way that I've done this. I'll show you what the process that I've used for that, just to get that. The only downside is that I'm going to have to effectively label this up, put it into position, and kind of fabricate the harness on the car. It'll be quite nice because in the end I can get it in like very close in terms of fitness and fitment, and make that all very nice, and then just trim it back, sheathe it in, Raychem DR25 heat shrink or whatever it is, and label it and do all that sort of stuff. But look, the other option is obviously just to bench make it. Now the other thing is, when you are doing that, be mindful of heat and abrasion. If you are building it as well from scratch, keep in mind that you might want to have some redundancies. So for me, this is the simplest of the connectors, but say here this is where my main sensors are running into this connector here, connector C. I might run an extra couple of analog wires up the back, just so that if I do want to put that in later, I can just attach a Deutsch connector or something like that to that pin and get that in very quickly. Same with the sort of the digital inputs if I want to control something down the track. So just one to be aware of. Otherwise, think about power feeds in terms of upgrading that stuff. So if you want to run a larger fuel pump down the track, you're not going to run into any dramas. Otherwise, read your ECU documents back and front over and over 17 times. You can see here's basically the plugs with all the pinouts from the ECU. You're virtually matching this up with the individual temperature, pressure, whatever sensors, throttle position type things, map sensors, and then you need to just sort of make sure those two are going to talk to each other, get that put together in terms of the wiring harness, bell it out to make sure it all works, and go from there. In terms of power sizing, one thing I can recommend, this is a Bussmann bust sort of relay block. It's a fused relay block, but what this enables you to do is it enables you to consolidate, for example, all of your power or all of your, say, your ignition switch switches for your relays into one bus thing. So you just run one cable in and it'll all switch together. Similarly, you can do that on the opposite side. So there's two sort of ports that you can bus these relays with. The advantage with that, if you think about it, I'll try and put up a relay diagram here on the screen, is that it's going to had a phone call that clapped out that last video, sorry. It's going to save you having a whole heap of mess like this. This is your traditional method of putting relays and fuses together. You can see that it turns into quite a bit of a mess with looping through power cables and signal cables to switch a whole heap of things. There's absolutely nothing wrong with doing this system. It's just that if you think about it, this is probably the messiest and hardest way to do it in terms of even just physically fitting all of your cables together. And then beyond that, you sort of, that bus system is sort of the, I guess, the poor man's version of going to a full PDM type setup with a program controller and all that sort of thing. The advantage with the relay and sort of fuse system is, of course, that it's easy to fix on the road. You know, you can have a spare relay and a spare fuse stuck into the block, and when you want to change it out, you just change it out. What I'm trying to do with this car is I want to run all of the vehicle stuff down one side, and I want to run all of the engine stuff down the other side, and just compartmentalize that stuff. So if something has a shit fit, you can just deal with that thing in isolation. I don't want to have to deal with, you know, in a normal car, your wiring loom does everything, and that's really a pain if you need to diagnose stuff. So if I label that stuff all on that side really well, and I sort of leave this stuff alone, and the fact that the harness is already built and already done by Ultima, I can just deal with that. The other thing I'll be putting under the dash to keep separate as well is I'm going to put in these little, that's just sitting on top there, a little fuse block, if I can see that. They're quite cheap, and I'm going to have one that's going to be switched 12 volts and one that's going to be permanent 12 volts. I'm just going to fabricate up a little panel here beside the AC here, and that will just enable me to run like my infotainment system and all that sort of crap off of that. So that way in the future, if I want to plug anything else in, there'll already be, you know, a few spare fuse spots there, and it sort of gives me some future proofing, but also isolates everything so that if I do have issues, I can sort of deal with it. You can see here's actually one of the plugs that I've already bound up and compartmentalized into what I would like how I'm going to run it out. So that, for example, is the idle air control. This one here is, what does that say on it? It's kind of hard to hold my phone and read at the same time. I don't know, some nonsense. But I'll show you how I'm going to sort of attack this just by looking at the simplest of these, which is the O2 sensor plug. So obviously, to start with, I've got just a plug that sits like this. The way that I've laid it out is I'll literally just have one end of the plug sitting up here on my roller. I run all the wires out here to the other end of my bench, and just had it sitting over here. Then literally it's a matter of looking on here. So the lambda controller is here, connector A, which is what we're dealing with. All of these redundant pins, all I had to do was just, as I said before, get a screwdriver, you poke it in those two little white tabs there, that slide pushes across, and then you just yank out the redundant wires. So we can see here on the back of that connector there, let me just try and move this, all those redundant ones which were otherwise filled with wires have just been pulled out, which leaves the ones that you really want. Then you're literally just looking at that connector, looking at the original diagram over here, identifying the ones that you want. So for example here, Lamb 1, which is A10, and then if we look over here, A10 is LA1, heater, positive black, is going to be going to wideband 1 on the left bank. Watch this be completely wrong now that I'm showing it to everyone. So here, that is the black with a brown stripe, is that right? Yep, black with a brown stripe. So I ran that all out. If we go right up here to the other end, here we go here. Is this it? No, here you go. Black with a brown stripe here. And we can see that's O2 left hand side, bundled together with the heat shrink. And then right at the very end, so I've got a right hand side one and a left hand side one. Each of these cables will be run into the vehicle and then cut to length. I probably haven't labelled them individually yet because I need to just cut them in, so I'm not going to have cut off the labels when I do that. What I'll be doing with that is just getting these suckers, which I printed out earlier. When you do use this, try and print them out in one go, because I actually end up with a bit of redundant with a bit of redundancy on the end of each of these prints. So for example here, that's not actually the one that I need, but you've got all the labels on here that you just cut with your scissors and then heat shrink into place. The only thing that I would comment with that is that you can have a bit of redundant stuff at either end that you can use just to sort of help bundle these cables together. So I'll try and find one maybe here. Yep, so there's just a bit of redundancy at the end here. I just use that cut off just to hold those cables in position. Now what I'll do is I just plug this into the ECU, feed it through its hole here, run it back down under the tank, back up in here. Obviously the exhaust system's going to need to be in position in this case with the O2 sensors in place, and find out where I actually want to mount the connectors, and then I just need to truncate it, and then I can use the heat shrink to get it into place.